10 terabytes of data between it. There's no memory locality issues, no cache issues. It's just one giant chip. And so when we were told that Blackwell's ambitions were beyond the limits of physics, the engineer said, so what? And so this is what happened. Over the course of the last 8 years, we've increased computation by 1,000 times. 8 years, 1,000 times. Remember, back in the good old days of Moore's Law, it was 2x, well, 5x every, 10x every 5 years. That's easiest math. 10x every 5 years, 100 times every 10 years. 100 times every 10 years in the middle, in the heydays of the PC revolution. 100 times every 10 years. In the last 8 years, we've gone 1,000 times. We have 2 more years to go. And so that puts it in perspective. The rate at which we're advancing computing is insane, and it's still not fast enough. That's the back, the DGX NVLink spine. 130 terabytes per second goes through the back of that chassis. That is more than the aggregate bandwidth of the internet. So we could basically send everything to everybody within a second.
Testing and optimizing layouts in this physically accurate digital environment increased worker efficiency by 51%. During construction, the Omniverse Digital Twin was used to verify that the physical build matched the digital plans. Identifying any discrepancies early has helped avoid costly change orders. And the results have been impressive. Using a digital twin helped bring Wistron's factory online in half the time, just 2.5 months instead of 5.
That's the way it's going to be in the future. We're going to manufacture everything digitally first, and then we'll manufacture it physically. This, as you know, was First Contact. 2012, AlexNet. You put a cat into this computer, and it comes out and it says, cat. And we said, oh my God, this is going to change everything. You take 1 million numbers, across 3 channels, RGB. These numbers make no sense to anybody. You put it into this software, and it dimensionally reduces it. It reduces it from 1 million dimensions. It turns it into 3 letters. 1 vector, 1 number. And it's generalized. You could have the cat be different cats. And you could have it be the front of the cat and the back of the cat. And you look at this thing, you say, unbelievable. You mean any cats? Yeah, any cat. And it was able to recognize all these cats. And we realized how it did it. Systematically, structurally, it's scalable. How big can you make it? Well, how big do you want to make it? And so we imagined that this is a completely new way of writing software. And now, today, as you know, you type in the word CAT, and what comes out is a cat. It went the other way. Am I right? Unbelievable. How is it possible? That's right. How is it possible you took 3 letters and you generated 1 million pixels from it, and it made sense? Well, that's the miracle. And here we are. It understood, not just recognizes the English, it understood the English. It doesn't just recognize the pixels, it understood the pixels. And you can even condition it between 2 modalities. You can have language condition image and generate all kinds of interesting things. Well, if you can understand these things, what else can you understand that you've digitized? The reason why we started with text and images is because we digitized those. But what else have we digitized? Well, it turns out we digitized a lot of things. Proteins and genes and brain waves. Anything you can digitize, so long as there's structure, we can probably learn some patterns from it. And if we can learn the patterns from it, we can understand its meaning. If we can understand its meaning, we might be able to generate it as well. We're going to invent a new way for you to receive, and operate software. This software comes basically in a digital box. We call it a container. And we call it the NVIDIA Inference Microservice, a NIM. What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. They could be open source. They could be from one of our partners. It could be created by us, like NVIDIA Moment. It is packaged up with all of its dependencies. And so this is a piece of software in the future that has a really simple API, and that API is called Human. And you'll assemble a whole bunch of chatbots. And that's the way software is going to be built someday. How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. That NIM would maybe understand SAP. The language of SAP is ABAP. It might understand ServiceNow. And it go retrieve some information from their platforms. It might then hand that result to another NIM who goes off and does some calculation on it. This is what you can do with a NIM. First thing you can do with it is customize it. We have a service called NEMO microservice that helps you curate the data, preparing the data so that you could teach this, onboard this AI. You fine-tune them, and then you guardrail it. You can even evaluate the answer, evaluate its performance against other examples. Remember, inside our company, the vast majority of our data is not in the cloud. It's inside our company. It's been sitting there, being used all the time, and gosh, it's basically NVIDIA's intelligence. We would like to take that data, learn its meaning, like we learned the meaning of almost anything else that we just talked about. Learn its meaning, and then re-index that knowledge into a new type of database called a vector database. And so you essentially take structured data or unstructured data, you learn its meaning, you encode its meaning, so now this becomes an AI database, and that AI database, in the future, once you create it, you can talk to it. 5 things. First, a new industrial revolution. Every data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged, generative AI. Third, new computer creates new types of software. New type of software should be distributed in a new way, so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you, because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. And third, these NIMs are going to help you create a new type of application for the future. Not one that you wrote completely from scratch, but you're going to integrate them like teams. Create these applications. And then lastly, everything that moves in the future will be robotic. You're not going to be the only one. Thank you. Have a great GTC. Thank you all for coming.